Good afternoon. I would like to thank everyone for being here today and Guy Elitzur for accepting my invitation to be the speaker. On behalf of Sabra Tech Hub, I would like to thank the Brazil-Israel Chamber of Commerce at Rio, Ribeirão Preto, and Santa Catarina, the Israel-Brazil Chamber of Commerce at Tel Aviv, and the Academic Incubator of Technology and Innovation, IATI-FEMA, for their support. And thanks also to Oxytrade for being our sponsor. Sabra Tech Hub is an initiative created by WISPLINE with the support of the Brazil-Israel Chamber of Commerce at Rio to promote the dissemination of Israeli technologies in Brazil. This event is part of a series of events that take place every other week. So if you guys like our event today, stay tuned for more interesting content that we will bring to you in the next weeks. In today's event, we will present EcoPhage, a product that protects crops against bacterial diseases that threaten agricultural production. This protection is achieved by using naturally occurring viruses, which are called phages, that have the ability to infect bacteria, but are safe and inert to humans, animals, and plants. And today, to talk about EcoPhage, I'm pleased to welcome Guy Elitzur, CEO. Thank you, Guy, and welcome.
Thank you very much, Fernanda. Thank you for the invitation. It's a pleasure being here today. While I'm sharing the presentation, I'll introduce myself. I'm the CEO of EcoPhage in the last year or so. Basically, I'm in the agriculture space for the last 15 years, coming from the business and the commercial side, dealing with different technology in farming and agriculture, whether it's crop protection, digital farming, vertical farming, and other. And we truly believe that the crop protection is going through a tremendous change. We're going to share part of these trends and part of this dynamic, and where we think we can integrate our solution and technology. So the crop protection industry is a $65 billion industry. More than 2.7 million trillion liters that is being applied year over year. Where you look at the pie, so the big portion is herbicide, and then insecticide and fungicide. There's a small segment that's called bactericide. In the next few slides, I'm going to share why we believe there is more opportunity within the bactericide segment. America is leading the way. Brazil, of course, US are the biggest agriculture market. Europe and Asia are following, and we see more and more innovation coming from these markets. And again, Brazil is definitely one of the biggest agriculture markets that apply more and more innovation in agriculture. Bactericide segment is around $10 to $12 billion, depends which market survey you're reading, growing 5 to 6% year over year. But what's interesting is the story behind the numbers, and the story behind the numbers goes as follows. For many years, I mean more than 2 decades, there were less of innovation and R&D focus and attention and grants that were allocated to bring innovation into the bactericide. The reason for that is the historical reason, where basically there's 2 or 3 big molecules that address most of the bacterial diseases over the years. And there was a feeling between the players in the industry that there's a less needs into bringing innovation. What happens is that in the last years, as a result of climate change, evolving of diseases, the current solution becomes less and less effective. And we see increasing yield loss as a result in many crops across globes as a result of no treatment or limited treatment. So we see the example of citrus greening, Pierce disease, ghost bacterial wilt in corn, and the list goes on and on and on. And the FAO talks about 20 to 30% of global yield loss is a direct as a result of bacterial diseases. Again, the current solution has low efficiency, increasing bacterial disease and toxicity that put the regulator in a position where it's limited or banning product in the markets, in the different markets. And you see some of the crops here, potato, tomatoes, and other long list of bacterial diseases and in crops that create huge damage. As a result of that, we have done some internal analysis, and we claim, or we argue, that there is at least additional 75 million liters of product that could have been applied only if there were innovative and potent product in the market, which roughly is $2 billion additional to the market, and thus the pie would have been a bit different. But what's important, or more important, is that the farmer would have more tools to address these evolving diseases and the limitation with the current solution. So what are the bacteriophages? The bacteriophages are natural viruses that were discovered in the 19th century, but due to lack of scientific tools, there are not too much of information known about them. Only the last 2 decades, there were more and more academic institutions and universities that have conducted research about phages. So what we know today about the phages, they are very specific, meaning each phage attacks a specific pathogen. The advantage for that, of course, that it doesn't have any harm for beneficial insects. It self-multiply. Basically, the phage is attached to the cells of the pathogen. It integrates their DNA into the cells. That's the way it kills it, and that's the way it multiplies itself. And of course, it's safe and biodegradable in a way that it's basically positioned itself as a good bactericide element to address bactericide diseases in agriculture. Here you see part of the trends of academic work and research that was done in the last 2 decades, and you see more and more articles about the impacts of bacteriophage against bacterial diseases in agriculture. That, as a result of that, created basically an ecosystem of bacteriophages, and we are part of this ecosystem. The company has licensed a technology from the Weizmann Institution. It's one of the leading research and scientific institutions. This basically technology was developed by Professor Rotem Sorek, one of the leading professors on a global level that have done a lot of research on phages. The technology was first licensed by a company named Biomex for medical purposes, and we have licensed this technology a couple of years later for agricultural purposes. So the embedded characterization of the phages, together with the ability to identify, map them, and characterizing what we're doing in EcoPhages, enable us to create a cocktails and a product for the crop protection market. In a nutshell, we have few main steps within our R&D platform. First, we are able to screen and characterizing phages in high throughput. Thousands of phages are being screened against targeted pathogen. Bear in mind that for each pathogen, basically, we're doing the process from scratch because of the specification of the phages, and we're locating the phages, the relevant phages. We're evaluating these phages against a multivariable analysis. We're checking the host range, meaning how many variety these phages can cover. Stability, toxicity, and other parameters are being tested in order to choose the most optimal phages. And then we are taking them through a genetic analysis to check their mechanism of infection. Of course, we're trying to bring as many as a mechanism of infection as possible. And then we assemble the phages into a cocktail, which we call a super cocktail. And then it's been synergized and formulated into a product and being applied like any crop protection product. And again, at the end of the day, it brings the phages into a cocktail, different mode of action, different host range, and different ways of acting to strengthen their performance, of course, to lower the chance of resistance and other parameters that eventually create a good and potent crop protection solution. In terms of time to market, so if we look at the synthetic chemical, we're talking about hundreds of millions of dollars into bringing new AI, new active ingredients into the market. It takes more than 10 years from research all the way to registration and commercialization. Biologicals are shorter in terms of time to markets and more cost effective. In our case, we're talking about 12 to 18 months from addressing a pathogen all the way to starting field trials, which is quite short in the industry of crop protection, which means in a relatively short time, we're able to test the product in the field and evaluate that against actual or semi-commercial plot quite fast. So another advantage of the bacteriophages and the platform that we have developed. Our first product is a product against bacterial disease in tomato. Tomato is a premium crop, part of fruits and vegetables, of course, and suffer from a few bacterial diseases. Two of them are, I would say, most common: bacterial spot and bacterial spot, Xanthomonas and Xanthomonas, their Latin name. And basically, at this point, the farmers are using copper-based solution and formulation, some antibiotics, and some biological product in some countries. All of them are suffering from limited controls. Some of them are from phytotoxicity and, of course, negative environmental footprint. And there's definitely a need for innovation in this space, as I explained before. And there's definitely, I would say, a place to bring more product and to integrate them into existing spraying program and to strengthen the performance, lower the resistance, and bring in the entire added value of a new product. Our first basically trials, we have conducted that in Florida. Florida considered to be one of the most, I'd say, leading tomato states in the US, one of the big markets in terms of tomatoes. We have done there from the trials from September to last December, 2 weekly treatment, 1 liter per hectares, and you have all the details here. And what's most important, what's more important is basically that the picture in the middle, which is our product EcoTac, we could see the difference in a site. I mean, just looking at the plants, the strength of the plant, the physiology of the plants, the color, the vigorousness of the plants, of course, the fruits, the size, the colors, all of them were quite different from the other plot. And then, of course, we moved to evaluate the numerical parameters. So I'll explain this graph from left to right. On the left side, you see the efficacy control, basically comparing our product into Coeside 3000. Coeside 3000 is a copper-based solution, which is the farmer practice in Florida and in many other tomato markets. And we could see here that alongside the growing cycles, basically our product could perform better than the farmer practice, 46 to 66% of control versus the 37 to 52% of control of the farmer practice, significantly better performance than the existing solution that the farmers is using. Again, alongside the growing cycles in different stages of the cropping cycles. In the middle, there's a formula that is being used and considered to be the accumulated level of disease. And here as well, we were able to see that we were able to keep the level of disease lower than the copper-based solution, significantly lower. And again, that's another parameter of checking the performance of a product. And on the right side, there is a disease severity. And here as well, our grain line, this is our product keeping the level of disease lower. And again, that's not trivial for a biological. Usually when you're bringing biological into the market, you're having 60 to 80% lower, I would say 20 to 30% lower performance, but you're adding other added value. In this case, we were able to show that we are equal or even better than the commercial practice. On top of that, we were checking few qualitative parameters, number of fruits, and from the left, and you see here that the numbers of fruit are higher than the plots that Coeside 3000 were applied. And on the right side, this is the weight of the marketable fruit. And here as well, the plots that was harvested using our product have higher weight of marketable. Now that's not surprising because usually that's part of the advantage of using natural components and that has better impact on the physiology of the plant and does better impacts to the economy of the farmers and better profitable to the farmer in terms of yield, quality of fruits and weight as well. This is basically our first ambition to create a spraying program from A to Z for tomato and peppers. These two diseases that we're talking about exist in peppers and tomatoes. And basically, this is our first recommendation to integrate our product. We're not, by the way, we're aiming to the conventional farming, not just organic, meaning the mass market of the tomato market. And our first recommendation would be to integrate our product within existing spraying program to lower chemical, to lower toxic product, and to replace that with some application of our product, and to see the impact as we saw in our in the last slide in terms of numbers and efficacy. There are more in the pipeline. Basically, we're using and leveraging this unique platform that we have developed together with the Weizmann Institution to issue more products. So the second on top of bacterial spot, which basically is planned to be submitted for the EPA, which is the environmental office in the US that approve using pesticide. We're planning to submit the package within 2 months, after mid of 2023. And we're working on other projects, fire blights in pears and apples, also considered to be dramatic diseases in these crops. Here's disease in grapes and in olives, and banana moko. If you look at the 5 big risks of growing banana, moko is part of that. It's one of them. It's considered to be a huge headache for the banana growers, and there's no solution for that, zero solution for that. And basically, banana growers usually will destroy the plot that this disease was discovered, just not for that to be sprayed to other plots as well. And it's more or less the timeline again, where as we spoke, was explained basically year and a half until field trials, and then the concluding of development, regulation, and commercialization. That's basically the process of any crop protection. In that case, we're able to shrink this process as a result of what I expect. So in a nutshell, basically the ability to take natural components and to create a platform in order to identify these components, understand their DNA, and to understand how they can integrate into a cocktail and being translated into a crop protection solution for bacterial diseases. That's what we're doing in EcoPhage. We truly believe that phages as a natural component has good potential to be integrated as a key element in many of the spraying program, and that's what we're doing. So appreciate again your time, and I'll be happy to answer any question that you have.
Thank you, Guy. Let's now start with the Q&A session. If you guys have any questions, just let me know. Just speak up. Just maybe to break the ice, I'm going to ask you the first question. While you were talking, something came to my mind, like when you spread viruses in the environment to infect bacteria, how can you make sure that the good bacteria in the environment will not be killed as well as the bad ones? So by creating an imbalance in the ecosystem, how can you make sure that you're not going to kill the good ones?
Good question. First, let me say that the bacteriophages or the phages exist everywhere. Air, soil, water, they exist everywhere. They operate without EcoPhage. That's their natural way of operation. Now, secondly, the advantage of them that they are very specific. So so phage will address specific pathogen, and that's also the only thing it can kill, and all the rest is basically agnostic to that. And that's part of the advantages of the phages being specific and being addressing specific pathogen, and thus don't have any harmful impacts on any other either pathogen or beneficial elements.
Great. So any other questions?
I have a few questions that I would like to make.
Sure. Hi.
Thank you for your talk. I am Aline from University of São Paulo and currently work with phages. I'm quite interested in knowing how do you address the problem of delivering the phages in the case of the vines infected with Xylella fastidiosa, because it's a xylem pathogen. So I'm quite curious about this.
It's a good question that we haven't addressed yet, because basically this project is at its first stages, so it's still basically being developed in our lab. So we didn't yet address or didn't yet need to face this type of challenge of moving these bacteriophages. But yes, bacteriophages has its own, I would say, limitation in terms of temperature and storage issue that need to be addressed. Part of the way that we are trying to address that is through the formulation, through adding a few elements in the formulation and other elements in order for the phages to be able to be stabilized a long time and be storage as needed for crop protection solution. So that's part of the way that we're trying to address this issue.
If I can ask another question, how you are going to deal with the phage resistance that's common issue when you treat bacteria with phages?
Good question. Great question. A question that concerns us a lot, and that's part of what we're doing in our development process. So there were a few elements that we're trying to, what we're adding, basically trying to aim this resistance issue. A is that we're checking that the resistance through our development. B is that we're collecting or assembling. It's a cocktail. It's not just one fudge.
Okay.
So the cocktail basically is different mode of infection, different fudges, different contamination mode, and that's part of attacking the pathogen from different ways, and by that reducing potential of resistance. Another element here is in some of the countries, for the sake of the US, you're able to register more than the fudges that you have in the cocktail. Meaning, if you have 5 in the cocktail, you're able to register 7 or 8 fudges, and basically replace them if any resistance issue come, without the need of going all the way from in the registration process, and the shifting or the replacement is not an issue, and thus you're able to keep on selling without or commercialization without the need of re-register this product.
Great, thank you.
Sure.
Any other questions? I have a question also. You guys are already having pilots in some countries. What countries are you using already your product?
So at this point, we're focusing on the US, and we've done trials in Florida mainly for tomatoes. We're doing some trials for fire blights in Europe, in peers. And again, we see good result, but it's initial field trials. So at this point, we're focusing there. As I mentioned before the calls, I was in Rio a couple of weeks ago. There was a big biologicals industry conference, and there's definitely I was more, I would say, more acknowledge the needs of new bacterial product. And the fact that I saw in Europe and in the US of lacking of innovation in bactericide, that's the same feedback I got after the conference from different stakeholders. So we're definitely starting to explore the Latin America market, but we're just starting that.
Great. So if you guys start to have a lot of demand for your product, would you be able to supply the product to Latin America? Where do you manufacture? Do you have facilities in Israel? How does this work?
So it's the process is, I would say, have a very high level of similarity to many of the fermentation processes for other organisms. There's of course some differences, but the major of the steps are the same. At this point, we're manufacturing that in Israel, but we definitely will explore in later stage the ability to manufacture that locally. And there's of course issues of regulation, cost, and other elements that need to be evaluated when time comes. But it's definitely something that we think we test, we evaluate that, but the actual evaluation, I would say, whether to do that only in Israel or in other targeted markets will be when time comes.
So at this point, you would be looking for partners here in Brazil to do some pilots, to test the technology here in the country.
That's correct. At this point, we're basically with our first product, and maybe even the fire blights. I'm not sure it's relevant for Brazil, but tomato is definitely an issue in Brazil, the second spot. And we're definitely basically looking for potential partnership in Brazil to evaluate the product, to evaluate our technology.
Great. So any other questions from the audience?
Very interesting, your product, and of course, Brazil is a huge market for this product, and I imagine that you are searching for partnerships here in Brazil. So we at the Brazilian Israel Chamber of Commerce, we are very interested in facilitating this interchange. So count on us when you need. And are you related to the Israel Brazil Chamber because Israel in Israel, we have the Israel-Brazil chamber. Sylvia Brand, I think, is the executive director. And we have a straight contact with her. So this would facilitate our contact.
I'm not familiar with this person, but I'd be more than happy to meet him and discuss him. And if you can facilitate that, that would be great from our side.
Okay.
Great. I'll put you in contact with Sylvia. Sylvia is the CEO of the Israel-Brazil Chamber of Commerce at Tel Aviv. So she's a good person to, just to contact. And also we have other people here in the audience as well that might be interested in also getting in touch with you later on to discuss potential partnerships. And so it's great. So any other questions or comments? So I have one more question about the application of the product. Is it straightforward to apply the product? Does it require any specific new machinery, or farmers can actually just use, apply with their own machinery?
So again, good question as well. We basically, part of the developing we're doing and the formulation that we're creating is making sure that for each crop there is different farmer practice, and the specific of the farmer practice is going to apply our product as same as any other crop protection that is using, so there will be no differences. The application, whether it's foliar or soil treatment or any other stuff, changes from one crop to the other, from one disease to the other. But at the end of the day, when we are bringing a product into the market for a specific crop, it will be applied like any other product. There's no need for any new machinery or a new process or stuff like that.
Great. And what about the cost-benefit analysis? I know the benefits because, bactericides, they are toxic. The bacteria gets over time resistance to bactericides. But what about the cost benefit analysis? Because the farmer is going to think about it like, if it's too expensive, maybe it's better for me to keep using bactericides. I don't know. So how is this cost benefit analysis? Is it too expensive?
So you have a list of good questions. So that's another good question. So cost is an issue. So, but the issue of the cost is not because our product is expensive. It's because basically the product that are being used by the farmers are very commoditized and thus are very cheap in that way. So what we're trying to do is being not much expensive. So we're talking about 15 to 20% more expensive. And we are replacing that with basically innovation, mode of infection, better economic, better yield, and other stuff. So eventually we believe that the farm will gain more when we're using our product. Still need to be proven, but it won't be double the price or 50% price. It will be a bit slight more expensive than the commoditized product, but we believe that it will bring a lot of monetized benefits to the farmer.
So the cost will basically more than compensate for the gain that they will have in production. They will gain more in production than that will cost to get your product, right? So
absolutely, yes, absolutely. That's what we see. Again, I show some of the slide about yield, about weight and stuff like that. But yes, at the end of the day, the bottom line of the farmer will be more profitable.
Great. So let's see if there is any other questions from the audience. No. You guys can always contact Guy later on. He's going to be available. There's I don't know if you noticed in our platform with Spline where the event is hosted. You guys can send messages to Guy later on through the platform. So I believe there's not going to be any problem if you want to contact him later.
There is a question.
Yes, there's another.
Oh, there's a question there. Oh,
yes.
So the question is, could you talk about the production process? Is it solid or liquid? So the production process is again mainly a fermentation process with some differences. Solid or liquid is highly depends on the formulation and the application. So it's both. At this point, the tomato is liquid, but it can be definitely solid. That's something that is, again, more impacted by the farmer practice, by different needs of logistic and stuff like that. That's been evaluated. Like in any other crop protection product that is being, there's no something specific for the fudges that force us to use that formulation or the other formulation. It highly depends on what the farmers are using. Again, we're trying not to change anything on the farmer practice in order for that to be integrated quite fast and quite easy.
Great. Any other questions? So I have one last question from my side. Do you have, maybe, of course you know about that because you are in the market, do you know if any other competitors are working on a similar solution to yours, like they're also doing research on phages to use in crops? Do you know if there is other competitors? Because sometimes we think that having competitors is bad, but at the same time, if you look at it again, it might be good because it helps to educate the market about the usage of, the benefits. Because if you are doing this alone, maybe it's harder to educate people. If there are other people, doing the same thing as you are, maybe it's you create like a critical mass of people discussing about this new technology, and adoption becomes easier. So do you know of any other competitors that are also doing this movement to implement this type of technology in the market?
So I absolutely agree with you. Competition is great because when you're a small company trying to bring innovation into any market, if you're alone, it's harder. And if you have more person talk about this innovation and do the education is much better. And especially that it's a giant market. So there's a place not just for 2 products or 3 products, there's a place for many products. And as many products as there are, I believe there is a place, again, for the giant agriculture market. So there are a few companies that are developing agriculture product based on bacteriophages. Not too many, but there are. By the way, if you look at the medical, the pharmaceutical industry, we're talking about some tens of fudge companies that develop pharmaceutical solution based on the fudges solution. So it's much more advanced, much more, I would say, progress in terms of using fudges for pharmaceutical issue. Agriculture, as in many other technology, is going a few steps behind the pharma. So there are not single-digit companies that developing a product based on the bacteriophages. We're meeting them in conferences. We have a great dialogue with them, and we truly believe there is more than one. There's a place for just one company in this space, especially where in the bactericide market that is a need for innovative solution.
Great. So, any other questions in the audience? So again, you are all welcome to send Guy some questions later on if you think about anything that you might want to ask him. So Guy, I'd like to thank you a lot for your presence here today. And again, on behalf of Sabra Tech Hub, I'd like to thank Brazil-Israel Chamber of Commerce at Rio, Ribeirão Preto in Santa Catarina, and the Israel-Brazil Chamber of Commerce at Tel Aviv, and the Academic Incubator of Technology and Innovation, IATFEMA, for their support. And thanks also to Oxytrade for being our sponsor. And Sabra Tech Hub is an initiative created by WISPLINE with the support of the Brazil-Israel Chamber of Commerce at Rio to promote the dissemination of Israeli technologies in Brazil. This event is part of a series of events that take place every other week. So if you guys liked our event today, stay tuned for more interesting content that we will bring over the next weeks. So again, thank you, Guy, and thank you all for being here today.
Thank you very much. It was a pleasure. Thank you all.
Thanks. Bye-bye.
Bye.